February 5, 1943. Chonkai Prison Camp, Thailand. 2:30 a.m. Lieutenant Tom Douglas pressed a single earphone to his ear, lying motionless on bamboo slats while 800 exhausted prisoners slept around him. Just 15 feet away, a Japanese sentry paced in the darkness, completely unaware that hidden beneath Douglas's sleeping mat was the most dangerous object in the entire camp: a secret radio receiver built into the false bottom of a coffee tin. What the guard didn't know was that this tiny device, no bigger than a man's hand, was about to become the most powerful weapon against despair that the Burma Railway would ever see. Over the next 2 years, this clandestine communication network would reach over 2,000 Allied prisoners scattered across 15 different camps, delivering something more precious than food or medicine: hope. But here's what makes this story extraordinary. These men weren't just listening to broadcasts. They had engineered the most sophisticated prisoner communication system in World War II history, using nothing but scraps, ingenuity, and Morse code knowledge that would make the difference between survival and surrender. But what they didn't know was that their greatest challenge wasn't building the radios. It was staying one step ahead of the Japanese Kempentai secret police, who were closing in. To understand why this communication network became so critical, we need to grasp the nightmare that was the Burma Railway project. In October 1942, the Japanese Imperial Army began construction of a 415-kilometer railway connecting Thailand to Burma. Their goal? Supply Japanese forces fighting in Burma while bypassing vulnerable sea routes. The problem? They needed to build it through 400 kilometers of malarial jungle across 600 bridges in just 12 months. Their solution was forced labor: 60,000 Allied prisoners of war and 200,000 Asian civilian workers. Among these prisoners were 13,000 Australians, 6,000 British soldiers, and thousands of Dutch and American servicemen captured after the fall of Singapore and the Dutch East Indies. The conditions were deliberately brutal. Prisoners worked 18-hour shifts in temperatures exceeding 40 degrees Celsius. Cholera, dysentery, and malaria ran rampant. Men died at a rate of 100 per day during the worst periods. The Japanese called it railway construction. The prisoners had a different name: the Death Railway.
Prison camps are psychological battlegrounds, and the Japanese understood this perfectly. Their most effective weapon wasn't brutality, it was isolation. Prisoners had no news from the outside world, no information about the war's progress, no knowledge of whether their families were alive. Wild rumors spread like wildfire through the camps. Germany has invaded Britain. Australia has surrendered. The Americans have given up in the Pacific. Lieutenant Colonel Philip Tosi, senior British officer at Kanchanaburi camp, later wrote, "The complete absence of reliable news was destroying our men's will to survive faster than the physical hardships. A man can endure almost anything if he believes it will end, but take away hope, and he simply gives up." By early 1943, suicide rates were climbing. Men were volunteering for the most dangerous work details, a form of slow suicide. Medical officers reported that prisoners weren't just dying from disease, they were dying from despair. The Japanese Kempentai secret police had specifically designed this information vacuum. They knew that isolated prisoners were broken prisoners. They confiscated all civilian radios within a 50-kilometer radius of the camps. Possession of any radio equipment meant immediate execution, no trial, no questions asked. But what they didn't know was that among these prisoners were some of Britain's most skilled radio engineers, and they were about to turn ordinary prison camp refuse into instruments of resistance. The breakthrough began with Sergeant Edward Ted Cawthron of the Fortress Signals Regiment and Lieutenant Tom Douglas of the Royal Corps of Signals, a BBC engineer in civilian life who understood radio technology better than most people understand their own telephones. Before leaving Singapore, Ted had done something remarkable. Knowing capture was inevitable, he had systematically collected and disguised radio components, vacuum tubes hidden in soap bars, wire wrapped around his belt, resistors sewn into uniform buttons. When the Japanese searched prisoners, they found nothing suspicious. Tom Douglas brought different expertise. He knew exactly how to build receivers using minimal components. In civilian life, he had designed transmission equipment for the BBC. Now he would apply that knowledge to create what prisoners called dicky birds, secret radios small enough to hide in a coffee tin. The first receiver was engineering genius disguised as garbage. Douglas built it into the false bottom of a coffee tin, just 2 centimeters deep. The tin still contained burnt rice. When guards checked it, they could pour hot water on the rice, and it would smell and taste exactly like prison rations. The technical specifications were incredible. A single 1.5-volt filament valve with a 45-volt high-tension battery supply. Douglas calculated the exact number of wire turns needed for the coil and the capacitor value for the tuning condenser to resonate on the 20 and 30-meter shortwave bands. Small holes in the tin's bottom provided connections for aerial, batteries, headphone, and tuning access. The aerial system was equally clever. Insulated copper wire hidden inside a 4-meter length of bamboo. During the day, it leaned innocuously against a tree. At night, operators brought it inside for listening. But this was only the beginning. The real breakthrough came when they realized they needed a communication network, not just individual radios. By March 1943, Douglas and his team had developed a systematic approach. They built 15 different receivers across the railway camps, each one disguised differently. Some fit into the bottoms of army water bottles with removable bases. Others were built into toolboxes and medical equipment. The most sophisticated innovation was their distribution network. They couldn't risk having all operators meet together, so they developed a relay system using synchronized pocket watches. News would be received at primary listening posts, written down in coded shorthand, then passed through a chain of messengers who memorized specific segments. The technical challenges were enormous. Batteries had to be smuggled in by sympathetic Thai traders. Charlie Letts, an Englishman living in Bangkok, managed to supply batteries, duck eggs, and quinine to multiple camps by convincing Japanese guards he was German. Components wore out constantly in the humid jungle climate. Operators had to become expert at field repairs, using nothing but scavenged materials. Most impressively, they developed security protocols that would impress modern intelligence agencies. Each radio was operated by only 2 people who never met other operators. If one was discovered, the others remained safe. They used code names, dead drops for written messages, and even created dummy radios filled with convincing but useless components to throw off Japanese searches. However, the biggest challenge was still ahead, distributing this information to over 2,000 prisoners without getting caught.
The impact was immediate and measurable. Harry Knight, Chief Petty Officer from the cruiser HMAS Perth, took over radio operations in late 1943. Every night he would lie on bamboo slats with a single earphone pressed to his ear, receiving BBC broadcasts from London, Radio Australia, and even Tokyo broadcasts in English. Knight developed an extraordinary system for information distribution. He would memorize entire news bulletins, then whisper them to trusted prisoners, who would spread the information through their work gangs. Within 24 hours, accurate news had reached every prisoner in camps, stretching across 200 kilometers of railway construction. The psychological transformation was remarkable. Lieutenant Colonel Tusi noted in his diary, "The difference in morale since reliable news began arriving is like watching dead men come back to life. Men who were giving up are now talking about what they'll do after the war." The broadcasts revealed crucial information. Germany was retreating on the Eastern Front. Italy had surrendered. American forces were advancing across the Pacific. But most importantly, they learned that the Allied forces knew where they were and were planning rescue operations. The network's most dangerous period came in August 1943, when Japanese Kempeitai discovered a radio at Kanchanaburi Camp. 2 innocent British officers were beaten to death in a failed interrogation attempt to locate other radios. The entire network went silent for 3 weeks while operators moved equipment and changed procedures. Tom Douglas developed increasingly sophisticated camouflage techniques. When floods threatened to destroy equipment, he rebuilt the entire receiver system using waterproof components. When Japanese guards began random searches, he created a mobile radio that could be completely disassembled and distributed among different prisoners in under 90 seconds. But what they didn't know was that their information network was about to face its ultimate test. By early 1944, the railway was nearing completion, and Japanese security was tightening. Guards were offering rewards for information about radio operations. Some prisoners, weakened by starvation and disease, were beginning to crack under interrogation pressure. The operators made a crucial decision. Instead of shutting down, they would expand the network. Using components smuggled by Thai resistance fighters, coordinated by the mysterious V-Man Heath of British American Tobacco Company, they built additional receivers and established backup communication chains. The results were extraordinary. When news came that D-Day had succeeded in Normandy, the information reached every camp within 48 hours. When prisoners learned that American forces had landed in the Philippines, suicide rates dropped to near zero. When they discovered that Japanese reinforcements were being withdrawn from Burma, they understood that their suffering had a definite endpoint. The network saved lives in measurable ways. Medical officers reported that prisoners with access to accurate news had significantly higher survival rates. Men who knew the war was being won fought harder against disease and maintained better discipline under brutal working conditions. But the real breakthrough came when they realized their communication network could do more than receive information. It could save lives directly.
In September 1945, when Allied forces finally liberated the prison camps, they found something unprecedented in the history of prisoner-of-war operations. A complete intelligence network that had operated continuously for over 2 years without detection. The numbers tell the story. Of the 15 radio receivers built and operated across the Burma Railway camps, only 3 were ever discovered by the Japanese. The communication network had reached an estimated 2,000 prisoners across multiple camps, delivering over 1,000 separate news bulletins containing critical information about war progress. But the impact went far beyond morale. The network had created a psychological resistance movement that helped maintain military discipline and organization among prisoners. This proved crucial during the chaotic final months of the war, when Japanese guards abandoned their posts and prisoners had to maintain order independently. Tom Douglas was awarded the Member of the British Empire, MBE, for his clandestine radio activities. After the war, he returned to the BBC and became engineer in charge of the television transmitting station at Sutton Coldfield. The original radio receiver he built was donated to the Royal Signals Museum, where it remains today as a testament to wartime ingenuity.
Harry Knight survived the war and returned to Australia, where he continued working in telecommunications until his retirement. He rarely spoke about his Burma Railway experiences, but in later years he emphasized that the radio network had been as important as medical care in keeping prisoners alive. The Thai resistance network that supplied batteries and components was revealed to be part of a sophisticated intelligence operation that had been reporting Japanese troop movements to Allied forces throughout the war. The mysterious V-Man Heath had been coordinating with British intelligence to maintain supply lines to multiple prisoner camps. But this was only the beginning of how clandestine communication
The engineering principles that Tom Douglas and his team developed in the Burma Railway camps became foundational to modern resistance communications. The techniques they pioneered, component disguise, distributed networks, security protocols, and emergency procedures, are still taught in military survival schools today. Modern Special Forces radios use miniaturization concepts that Douglas first implemented in 1943. The idea of building receivers into everyday objects became standard practice for intelligence agencies worldwide. Even the battery conservation techniques they developed are still relevant for modern field operations. Perhaps most importantly, their work proved that communication networks aren't just about technology. They're about human psychology. In an age where information warfare is a primary battlefield, the Burma Railway network demonstrated that accurate information can be more powerful than weapons in maintaining morale and resistance. The story of the Burma Railway communication network reminds us that the most sophisticated technology means nothing without the human ingenuity to implement it under impossible conditions. These men took radio components that would fit in a coffee tin and created a communication system that kept hope alive for 2,000 prisoners across 2 years of unimaginable hardship. Today, when we take instant global communication for granted, it's worth remembering that sometimes the most important message isn't sent through satellites or fiber optic cables. It's whispered by one person to another in the darkness, carrying news that tomorrow might be better than today. If you found this story of wartime problem-solving fascinating, make sure to subscribe for more incredible engineering stories from military history. And remember, every time you tune in to a radio broadcast, you're using technology that was perfected by desperate men with nothing but scraps and determination, proving that human ingenuity can triumph over any obstacle.